Alright guys, here we go. We're going to work on Parametrics 2, quiz 51 here. So the first question says, find the slope of the tangent line to the curve, x of t equals cosine cubed at, y of t equals sine cubed at, at the point where t equals pi over 3. So to get the slope, we need to do dy dt over dx dt, and that will give us dy dx, which is always slope, evaluated at t equals pi over 3. So that's what we're going to do. We're going to take the derivative of this guy first. So dy dt is equal to, remember that's the same thing as sine of 8t and all that raised to the third. So 3 sine of 8t squared. And then the derivative of sine is cosine of 8t. And then the derivative of 8t is 8. So 8 times 3, 8, 16, 24. So 24. All right, and now dx dt, right here, same thing, 3 cosine 8t squared, and the derivative of cosine is negative sine of 8t, and then times 8, so dx dt is 8, 16, 24, negative cosine squared of 8t, sine of 8t. Okay, now I'm just going to put dy dt over dx dt, guys, and let's see what cancels out. So dy dx equals 24 sine squared of 8t cosine of 8t over 24 cosine squared of 8t sine of 8t. Okay, so it looks like the 24s cancel out, and I lost a negative somewhere. There we go. There's my negative. Here's my negative, guys. And then one of these cosines cancels out, and then one of these sines cancel out. So I have sine over cosine, which is the same thing as tan. So let me write it right over here. Dy dx evaluated at t equals pi over 3 is equal to negative tan of 8 times pi over 3. So that turns to 8 pi over 3. So let's see what that is. So 8 pi over 3 is equal to the same thing as, let's see, 3, 6, 7, 8. So that is 2 pi plus 3, 6, 7, 8. 2 pi over 3. So see, this is 8 pi over 3, the same thing as 2 and 2/3, right? Or 8 over 3. So 8 over 3 is 2 and 2/3. 2, 6, 7, 8. Yep. So what I'm trying to say is that you have 2 and 2/3 pi. So you did a whole 2 pi. You did one revolution, and then you went another 2 pi over 3. That's that 2/3. So you did a whole 2 pi, one revolution, and then you went 2/3 pi. So on the unit circle, you did this. You did, well, let me do it in black. You did bam, and then you went boop, right there at 2 pi over 3. So 2 pi over 3, y is positive and x is negative. So square root of 3 over 2 divided by negative half. So there it is. Negative divided by negative. Well, I guess first this is just negative square root of 3. But remember that you have a negative here in the front. So you have negative times negative square root of 3. So it's just square root of 3. Yeah, that was kind of hard, guys. Sorry for all the work there. Hopefully that made sense. If it didn't, let me know. All right, let's see. Find the equation in x and y for the line tangent to the curve at the point where t equals 2. So I need a point and a slope. So I'm going to plug in a 2. So x of 2 equals 4 times 2, which is 8. And y of 2 is cosine of 2 pi, which is 1. So my point is 8, 1. Find the equation. Okay, so now I need my slope. So obviously it's a horizontal tangent, but at the time we don't know that, right? So here's my slope, guys. dy dt divided by dx dt. So dy dt, the derivative of cosine is sine. So, or negative sign, right? Negative sine pi t times pi. So I'm going to put the pi here. Over the derivative of 4t is just 4. And evaluate this at t equals 2. And you get negative pi sine of 2 pi over 4, which is 0. So y minus 1 equals 0, x minus 8. I know, you don't have to do any of that. You know that 0 times anything is 0. So there it is, y equals 1. Hopefully that made sense, guys. Let's keep going. All right, so here we go, guys. I want a tangent line. It says find the equation next one for the line tangent to the curve at the point 1181. So use this to help you find your t value, guys. Notice it says y of t equals t to the 4th. So what number raised to the 4th power will give you 81? I believe that's 3. So verify that if I plug in a t equals 3, that you'll get the point x coordinate 11. So 4 times 3, that's 12. 12 minus 1, that's 11. So the t value is 3. I already got my point. I need my slope. So dy dt divided by dx dt will give us dy dx. And then remember, we're going to evaluate that at t equals 3. So 4t cubed over 4. The 4's canceled out. And we're evaluating this at t equals 3. So 3 to the 3rd. Let's see what we get. 3 times 3 is 9. 9 times 3 is 27. So there we go. So that's my slope. So I'm going to write y minus 81 equals 27. X minus 11. And then we're going to distribute like so. So let's see. y minus 81 equals 27x minus, and I don't know what 27 times 11 is. So let's see what that is. Let's hear this. 27 times 11. 297. And I noticed that there's a zeros here. So that means I'm going to move everything to the left. So move everything to the left here like so. So let's see. I'm going to write it up here, guys. Negative 27x. Then I guess a plus y. And then negative 81 plus 97. So I'm going to write plus. And then so let's see. 297 minus 81. Minus 81. 216 equals 0. So let's look for that. And at first glance, I mean, let's see. 27x minus 4y minus 216 equals 0. Let's see. Positive, negative. Okay. It can't be this one. I mean, I guess if you moved everything to the right, I would have a negative 216. But notice the 4y is there. So it can't be that one, guys, because I just get y here, see? And it can't be that one. Let me see. It can't be this one either. So I'm noticing a theme. So you see how there's all the y's have a 4? So that means multiply everything here by 4. So when I multiply everything by 4, here's what we're going to get. 27 times 4, 108. So negative 108x plus 4y plus, and then I'm going to multiply 216 times 4. And I know some of you can just do it real quick, right? 216 plus 216 plus 216 plus 216, 2468, and then 1632, 64. So 864. So plus 864. All that equals 0. So it can't be this one. That's a 27, that's a 4. Notice, so it has to be a 108 and a 4. 108 and 4, but they have to be opposite signs, negative positive or positive negative. They both have the same signs, out. Negative positive, so we're onto something here. But notice this one has a minus. So if I have a negative positive, and it should have been a positive. So that one's out. That one's positive, that one's negative, and then that one's negative. Yep, that's a 1. And I know what you're saying, like, Chavez, what's going on? I don't see that. Well, if we divide everything by negative 1, guys, that's 108x minus 4y minus 864 equals 0. See? So there it is. Positive 108, negative 4y, minus 864 equals 0. So the way you tackle these, make sure that whatever coefficients in front of the x and whatever coefficients in front of the y, that they have to be opposite polarities. Positive, negative, negative, positive. So it can't be letter A because, why do we say that? Because that one's a 4, that one's a 27. It can't be letter B because both of them are positive. It can't be letter C because the 4y was a positive and the 864 was a negative, and both of them have to have the same polarity, see? So either they're both positive or they're both negative. So there it is. So it has to be letter D. Notice letter E has both of them the same polarity, so it can't be that one. So be careful, guys. Be careful. They're tricky. All right, let's see. Find the equation x and y for the length time to the curve at the point 1, 5. Okay, notice that's the x and y coordinate, guys. So what I'm going to do is, the only way you can get a 1 is if t equals 2 on the x coordinate. So then verify that that's what you get on the y value. 2 squared is 4. 4 plus 1 is 5. So there it is. So t equals 2. I need a slope. So we're going to do the same thing. dy dt, 2t, dx dt. Let's see. That's 2t to the negative 1. So negative 2 over t squared. All right, here we go. So I'm going to write 2 times 2 over negative 2 over 2 squared. So I get 4 over a negative 1/2. So that's a negative 8. That's my slope. Y minus 5 equals negative 8. X minus 1. It did say tangent line. Y minus 5 equals negative 8x plus 8. And let's see, I'm going to move everything to the left. So 8x plus y, I'm just moving that to the left. And then to the left, 8, 9, 10, 11, 12, 13. Minus 13 equals 0. Notice they all have 0. So that's what I'm looking for first, guys. I'm looking for my original first. I noticed that I don't have that, but I do have, I see either a 2x or a 4x. And I noticed that my polarities have to be the same for my x and my y. This letter A doesn't have a y, out. X and y have the same polarity, maybe. We'll see in a little bit. Letter C doesn't have a y, out. Letter D doesn't have a y, it's out. And maybe. So it's between B and E. Next, I noticed that both of them have 4x, so that means I have to divide everything by half, or divide everything by 2, which is the same thing as multiplying everything by half. So if I multiply everything by half, let's see, 4x plus 1/2 y, and then minus 13 over 2 equals 0. OMG, there it is, letter E. 4x plus half y minus 13 over 2 equals 0. So there it is, guys. All right. All right, guys, here we go with number 5. So number 5 is the same deal. Find an equation in x and y for the line time to the polar curve. And here's your polar curve at theta equals 0. The first thing you need is you need an x and y coordinate. So your x is equal to r cosine theta, guys. And your y is equal to r sine theta. So you need a x and y point because they want a tangent line. So that's exactly what we're going to do. We're going to plug in theta equals 0 here. So x equals, parenthesis, 20 minus 10 sine of 0 times cosine of 0. So that's going to give us sine of 0 is 0, and then you're going to cosine of 0 is 1, and 1 times 20 is 20. And then for y, we're going to do the same thing. 20 minus 10 sine of 0 times sine of 0. Well, sine of 0 is 0. 0 times anything is 0. So there's our coordinate right there. So our coordinate is 20, 0. Okay, so now we need a tangent slope. So we're going to have to do product rule here, guys. So product rule, first, second, and first, second. Remember that this is my theta there. Now I'm just putting a theta in that way, because you know if everything's a constant, then it's just 0, right? Because the derivative of a constant is 0. All right, so here we go. All I'm doing is dy dx. So I'm finding my dy d theta first. So first, 20 minus 10 sine theta times root of the second. Root of a sine is cosine. Plus second times the root of the first. And the derivative of negative 10 sine theta is negative 10 cosine theta. All right, there it is. I'm going to plug in theta equals 0. So dy d theta when theta equals 0 is, let's see, sine of 0 is 0, but cosine of 0 is 1. So I get 20 plus, and then sine of 0 is 0, and cosine of 0 is 1, but 0 times anything is 0. So I get dy d theta is 20. So now let's find dx d theta, and we're just going to divide them. So here we go. I'm going to write it down here. Dx d theta equals, and I'm doing the same thing, guys, but with the x up here. So first, times root of the second, root of cosine is negative sine, plus second times root of the first. So the root of a negative 10 sine theta is negative 10 cosine theta. All right, let's plug in theta equals 0. So theta equals 0, so let's see what we get. So theta equals 0, that all goes away. And cosine of 0 is 1, and then cosine of 0 is again 1, so negative 10. So dy dx when theta is 0 is, I get 20 divided by negative 10. So negative 2. All right, now that I know that my slope is negative 2, here we go, guys. I'm just using my point. Y minus 0 equals my slope, negative 2, parenthesis, x minus 20. So y equals negative 2x plus 40. And there it is. All right, let's keep going. Find an equation x and y for the line of tan to the polar curve r equals 7 cosine 2 theta at theta equals pi over 2. So again, you need a point and a slope. So we're doing the same thing. X equals r cosine theta, so 7 cosine 2 theta times cosine theta. Y equals 7 cosine 2 theta times sine theta. If you plug in the pi over 2, cosine of pi over 2 is 0. So 0. Because 0 times anything is 0, right? All right, so now let's do the y value one. Sine of pi over 2 is 1. So plug in a pi over 2 into this guy. So the 2's cancel out. So you just get cosine of pi, which is negative 1. Negative 1 times 7 is negative 7. So my coordinate is 0, negative 7. All right, and now let's find out our slope. So let's do dy d theta over dx d theta. So dy d theta equals, so I'm doing product rule again, guys. First, 7 cosine 2 theta times root of the second, root of a sine is cosine theta, plus second sine theta times root of the first. Root of a 7 cosine 2 theta is going to be negative 7 sine 2 theta times 2. So let's see what we get. I'm plugging in pi over 2. Cosine of pi over 2 is 0, so I get 0 there. Plus sine of pi over 2 is 1. Again, sine of if I plug in a pi over 2 in here, the 2's cancel out and you get sine of pi, which is 0, and 0 times anything is 0. So there it is, guys. I got a 0 for dy d theta, so my slope is 0, but you got to make sure that your dx d theta is not 0 as well. Because if dx d theta is 0, then it's possible that you have a vertical tangent, which would be like x equals something, right? X equals 0 or something. So do that real quick, dx d theta. So let's see. First, so I'm doing this one right here. So first, 7 cosine 2 theta times root of the second. Root of a cosine is negative sine theta. Plus second cosine theta times root of the first. Let's see, negative 14 sine 2 theta. I already went ahead and did chain rule, guys. Negative 7 sine 2 theta times 2. So 14. All right, if I plug in pi over 2, let's see, sine of pi over 2 is 1, so I get a negative 1 there. And then pi over 2 in here. And the 2's cancel out. Cosine pi negative. Negative times the negative is a positive. So 7 plus, and then 0. So there it is. I get a 7. So 0 divided by So my dy dx at theta equals pi over 2 looks like 0 over 7, so it's 0. So I have a horizontal tangent. So there it is. So it's just going to be my y value, whatever that is. So y equals negative 7. And if you don't like that, guys, just go y minus 7 minus a negative 7. So plus 7 equals slope x minus 0. I mean, but it's kind of silly to me to do all that because I don't really think you need to do that, guys. Ooh, I just deleted all that. My bad, guys. But see, anything times 0 is 0. Just move the 7. Y equals negative 7. Yeah, I know. It's kind of silly. You don't have to do that. All right. Sorry for deleting that. It accidentally deleted. All right. Next question. Question 7. Parametrize the curve y equals negative 3x cubed by a pair of differentiating functions with, to determine the tangent line at the origin. Okay. You actually don't need to do any like real math, or at least not much. Notice they already tell you what the curve is, and let's see. They're telling you that the derivative square plus the derivative of that square does not equal 0. Then determine the line tangent at the origin. Okay, so negative 3x cubed looks like this. See, that's all it is, guys. So right at the origin, you have this tangent, and that tangent is y equals 0. So tangent line x equals 0, out. Tangent line x equals 0, out. Tangent line y equals negative 1, out. Tangent line y equals 0, maybe. Tangent line y equals 0, maybe. It's between those two. So now next, how do I get this equation, negative 3x squared, from this? So notice that they tell you that y equals t. If I plug in this expression in there, so they're telling you that t equals y. So then you substitute that into the expression they give you. So x equals negative 3 parentheses, and instead of a t, I'm going to put a y to the third. Notice x equals negative 3y cubed. That's not the equation they give you, guys. They give you negative 3x cubed. So it can't be that one. It has to be this one. Notice when x is t, I can just do a direct substitution. If x equals t, and let's plug it in right there. So I'm just going to go negative y equals negative 3 parentheses x is t. So I can just go x to the third power. Or look, that's the equation they give you. See? Y equals negative 3x cubed. Y equals negative 3x cubed. So there's the answer. Hopefully that makes sense. All right, let's see. Find the points in the xy which the curve has a horizontal tangent. Well, the only way to have a horizontal tangent is if your dy dx equals 0. So we're going to find where dy dt is 0, this guy. Okay, so how do we do that? Well, let's just take a derivative of that. So dy dt equals 3t squared minus 12. I'm going to equal that sucker to 0. 3 parentheses, so I'm going to have t squared minus 4. And I'm going to have two t values. So I get t equals plus minus 2. So let's plug in t equals negative 2 and see what value I get. So when t equals negative 2, plug in negative 2 in there. So let's see. Negative 2 squared minus 5 times negative 2. Negative 2 squared is 4. Negative times the negative is a positive. So 5 times 2 is 10. 10 and 4 is 14. So I see 14. All right, let's plug in a negative 2 into the other one. Negative 2 to the third power is negative 2 to the third power. That's negative 8 minus 12 times negative 2. So negative 8 and the negative times the negative is the positive plus 24. 24 plus negative 8, 24, 14, 16. So 14, 16 is a point. Nope, nope, nope. Have it there. It's probably letter D. Obviously, we know it's letter D. But check the other one. Don't just take that one, guys. Also check at t equals 2. So here, I'm going to do it in a different color. So I'm going to plug in t equals 2 now. So if I plug in a 2 in there, x of 2, let's see what we get. 2 squared minus 5 times 2. 2 squared is 4. 5 times 2 is 10. 4 minus 10 is negative 6. So negative 6, comma, 2 to the third power minus 12 times 2. 2 to the third power, that's an 8. 12 times 2 is 24. So 8 minus 24 is negative 16. So there's my point, and here's my other point. So there it is, negative 6, 16, negative 6, negative 16, and 14, 16. All right. Find the points at which the curve has a horizontal tangent. Again, it's the same thing, guys. The only way to get a horizontal tangent is, remember this, what you're doing, right? This is your dy dx. And the only way that will ever be 0 is if this part of the expression is 0. So set your dy d theta equal to 0, guys. As long as your dx d theta is not 0, right? So dy or dy, and I put a theta there, but I noticed there's t's on this. So on this one is dy dt over dx dt. And that is your dy dx. So set your dy dt equal to 0 here. Let me see. Find the points at which the curve. Yep. Okay. So here we go. dy dt equals the derivative of 3 sine t is going to be 3 cosine t. And that is going to be 0 anytime t is equal to pi over 2 plus pi n. So let's plug in a pi over 2 into both of these expressions because it's going to be repeating over and over again, right? But why did I put a pi n here, guys? Because we're talking about cosine t, and where's cosine 0? Here, and notice that they're related by pi. So I put a pi over 2 plus pi n. That's where cosine is 0. So let's plug in a pi over 2. So if I plug in a pi over 2, let's see. If I plug in a pi over 2 in here into that, the 2's cancel out and I get pi. And then sine of pi is 0, so 0, comma. And if I plug in a pi over 2 on this one, pi over 2 is 1. 1 times 3 is 3. So there it is. Now what happens if I plug in a 3 pi over 2? Because that's what happens with the pi n, right? Where n is any integer. So if I set n equal to 1 and I add pi, so that's 3 pi over 2. So I already checked pi over 2. That's that one. What if I have 3 pi over 2? So 3 pi over 2, sine of 3 pi, again, that's still 0. And then sine of 3 pi over 2, that's negative 1. Negative 1 times negative 1 times 3 is negative 3. So there it is. Okay, and now we got the last one. Okay, same thing, horizontal tangent. So I want dy dt to equal 0, guys. Again, remember, we're not robots. We're doing this. We're doing this. That's a big there. Where that's 0. And the only way that's going to be 0 is if dy dt is 0. So I'm just taking a derivative, dy dt equals, so the derivative of 4 cosine t is going to be negative sine t. And where's that 0? Well, sine is 0 at these locations. So 0 plus pi n. So it's going to be, so t is 0 at pi n. 0, pi, 2 pi, 3 pi, where n is any integer. N is any integer. Okay, so let's test it out. Let's test out 0. If I plug in a 0, I get, so I'm plugging in 0 first. I'm going to plug in 0, pi, and then 0 pi and 2 pi. But 2 pi is going to give me the same thing as the 0 one. So if x equals 0, I get 2 for x. And cosine of 0 is 1. 4 plus 1 is 5. If x, so there it is if x is 0. If x is pi, let's see, I get again 2 for x. And 4 minus 1, that's 3. And so there it is. And if x is 2 pi, I should get the ones that back at 0. So if x is 2 pi, sine of 2 pi is 0, so I get 2 again. Cosine of 2 pi is 1, so I get 5 again. So 2, 5. All right, there it is, guys. Hopefully all that made sense. And yeah, hook it up with a thumbs up if it helped. All right, talk to you guys later, guys. Bye.